All right, so today we are working on solving rational equations algebraically and graphically. So we're going to start this off by just talking about a really simple fraction. And I want us to focus on the how we would solve this, not necessarily what the answer is, because we should be able to tell just by inspection that, hey, if we're solving for x, it should be equal to 2 because 4 over 6 is the same as 2 over 3. But if we want to think about mechanically what's happening, we would want to cancel out the denominators on both sides to help us solve this. All right. So if we go 6 on the left to cancel out that 6 on the bottom of the 4 over 6, we'd also have to multiply 6 on the other side, right? Everything you do on the left, you got to do on the right. That cancels out that 6 there. Then we'd have to do that same thing with the 3, right? Try to cancel out the 3 on both sides. So we're effectively what happens here is since the 6 cancels out on the left, we effectively cross multiplied here to get 3 times 4. And we also cross multiplied here to get 6 times x on our left and right sides. And what that gives us is 12 equals 6x. Then we could divide by 6 on both sides and get a value of 2 equals x. So we're going to take that process, formalize it into some notes, and then practice it with some more complicated examples. So if you head to your note sheet, we have a couple steps to knock out, or just write down steps to solving rational equations. First thing we're going to do is cancel out the denominators by using that cross multiplication. Then we're going to use algebra to solve for the variable. So all of our problems are going to look a little bit different as we go, but just make sure to harness those skills that you've been working on all year. And notice that in your notes, I threw this cross multiplication formula on there just as a nice reminder. And we're going to use it basically anytime we get one fraction equal to another fraction. So example 1. We have 3 over x plus 2 equals 4 over 2x minus 1. So if we want to just kind of start our cross multiplication here, I am going to multiply 3 times 2x minus 1. And notice how I am throwing parentheses in there to make sure I trigger that distribution property. And then 4 times x minus 2, or x plus 2. Okay, that is effectively what step 1 was. Okay, we have canceled out the denominators by cross multiplying. Now we need to use algebra to solve the rest of the equation. So we're going to start by simplifying. So we distribute in with the 3, so we get 6x minus 3 equals, distribute in with the 4, we get 4x plus 8. Then we're going to try to get all of our variables to one side, all of our constants to another side. So I'm going to try to move this 4x over to join my 6x. We get 2x minus 3 equals 8. I'm going to move this 3 over to start getting it away from my x's. I get 2x equals 11. And then I'm going to divide by 2 on both sides to get my x alone, and that gives me x equals 5.5. So let's try this now in example 2. A little more complicated of a problem because we have binomials on all of our numerators and denominators, but we can still kind of follow that same process, all right? We're going to set up our cross multiply first before we do anything else. Give myself a little more space here. So that first one, we're going to have x minus 2 times x minus 4 equals that second cross multiply, so we get x plus 3 times x plus 1. Then we can start simplifying. So we multiply these out, we get x squared minus 2x minus 4x plus 8 equals x squared plus 3x plus 1x plus 3. All right, now this looks a little funkier because we do have, actually I should simplify this first before we start talking about the next step. X squared minus 6x, we got some like terms we can combine. with the minus 2x and minus 4x plus 8, and equals x squared. We can combine that 3 and 1, so plus 4x plus 3. Then we have to move over our variables to one side, including those x squared. So if I subtract that x squared from the right, subtract that x squared from the left, you'll notice that it actually cancels out. So we just get negative 6x plus 8 equals 4x plus 3, which makes our problem a little easier to handle. So I'm going to then move my 6x over to the right. We could also go the other direction, move the 4x over to the left if we wanted. Either way is okay. We're left with 8 equals 10x plus 3. Okay, we'll slide that 3 over by subtracting it on both sides then. We get 5 equals 10x. And then if you divide by 10 on both sides, we'll get our answer, which gives us x equals 0.5. So let's do one more problem. And I noticed this morning that the problem I printed for example 3 on your note sheet is incorrect. So go ahead and cross that out and place this as our next problem. I just wanted to give you one that you should absolutely be able to do on your own, and then be able to check against my work after you've tried it. So go ahead, update your sheet, and pause your screen, give it a go, and I'll start working through this. So we cross multiply, we're going to have that 5 times x minus 2. Second cross multiply setup, we have our 2 times x minus 7. Okay, we distribute in the 5, we get 5x minus 10. Distribute in that 2, we get 2x minus 14. Then we're going to start trying to get our variables all by themselves. So I'm going to subtract 2x from both sides, subtract 2x from both sides. We get 3x minus 10 equals, that 2x cancels out, so we're left with negative 14. Now I can add 10 to both sides. We get 3x equals, and negative 14 plus 10 gives me negative 4. So now I can divide by 3 on both sides to finish out my problem. And we can either write x equals negative 4 over 3, or you can write it as a decimal, which would be, let's punch it in the calculator real quick, negative 4 over 3 would be negative 1.3 repeating. Now, similar to the work we did yesterday, when we're stuck with a difficult problem, we can use Desmos to solve this stuff. And I guess really, we should cross off these words right here. We can just straight up use Desmos. We don't even need to guess and check or check our answer. We can just straight up solve this thing graphically. So what we're going to do is we're going to take the left side of our equation here, this 2x minus 4 over x. We are going to plug that into Desmos as one of our equations. So 2x minus 4 over x. That's one equation there on the left. And the other equation we want to plug in is on the right, x plus 10 over 14. And if we do that, you're going to see that, hey, we get a couple of intersection points. And if I zoom in on these intersection points and look at what the x values are, we get, oh, just lost them. We get x values of 4 and 14. So in our notes, what I'd recommend writing down is if you graph these things, then we get from graph intersections x equals 4 and x equals 14.